Hello everyone and welcome to this week's video. In this video and generally speaking this week we will be discussing volume. But before we do, I would like to try and explain uh, the third dimension basically because we've only ever talked about two dimensions in geography, in geometry. So before we get into three-dimensional shapes, I want to try and explain what the third dimension means. So in all the shapes that you've seen up until now, we had two dimensions. So you could either look at it and go right and left, or you could go up and down. That was one dimension, right and left, and another dimension, up and down. Now we are going to add in a third dimension. So and you can see right here that we have what is now a third dimension, because now you can move along the green line, right? You can move along the red line, but you can also move along the blue line. So whereas before you could only really measure the surface of things, so how much area did they take up, couldn't really measure their volume. So that, I mean, how much space did they take up? Because, for example, we see here a cube. It takes up this amount of space, but if we wanted to, we could make a cube that takes up a whole lot more space. So you can see that this cube here is much, much bigger than this little tiny one that we started with. So how would we say that? How would we measure that? And what would we measure that? Um, Basically, like when we were talking about two-dimensional shapes, we described the size of the shapes by their area, basically, how much surface they covered. But now we can talk about how much space each shape takes up. So this little one here takes less space than this one. We do that by measuring the volume of these shapes. So I want you to look closely at how they move, because we won't be able to do these exercises in this program. So you'll kind of have to imagine what they would look like, basically, if they were like that. So I want you to look carefully at how they move, basically how they change depending on from where we look at them, right? So let's keep that in mind as we go over to the program we usually use. So we talked a little bit about how we would measure the size of the shapes, and we said that it's something that we do with volume. So volume basically describes the amount of space that something takes up. So to give you an example now, I will be making a box that's square that we have known up until now, and I want you to imagine that this square has all of its sides being exactly, let's say, 1 meter. Let's just imagine, of course it's not, but let's imagine for a little bit that it is in fact 1 meter. Okay, well, look what's going to happen now. I'm going to make another box, and then another box, and then another box, then one more, and one more. Now each of the sides in these boxes are exactly 1 meter, right? Okay, well, now imagine that I cut this out of, if this was paper, let's imagine that I cut this out, right? I cut all of this out, and then I folded it and then covered it off with this piece. What I would get is a shape that is called a cube. And you've probably heard this before when we say, for example, a Rubik's Cube, right? You've all seen Rubik's Cubes. A cube is a three-dimensional shape in which all of its sides are equal. Sorry. So if we took this and we folded all the pieces onto one another, we would get a cube. We would get this, right? So here it's almost as if it's see-through, right? Now I can't turn it like we could turn the shapes in the other program, unfortunately. So if I try to turn it, what happens? You see what happens. Right now it's not the same. I can't move around like I was doing before. So we'll just have to try and use our imagination a little bit. So this is a cube. Again, a cube has, you can see that all of its sides are the same, and it is comprised, if you go back, you will see that we made it out of 6 squares. So this is a three-dimensional shape. Let's talk a little bit about the terminology. Oh, wait. Now you can see that I actually didn't make it quite right. So here, this line should have gone here. And this line needed to come all the way across. All right, so first of all, some terminology, because the terminology is not actually the same as what we had with two-dimensional shapes. So we said that the three-dimensional shape that we have here, so the cube, is made up of 6 squares. Each square, so here, for example, this part, this front part, let's pretend for a minute that this side was actually not see-through. You couldn't just see through it, right? So you can see here that we have a square that is one part of the cube. Each of these parts of the cube is known as a face. So here we have a face of the cube. Here on top, we have another face of the cube. Here on the side, we have another face of the cube. In the back, on the bottom, and on the left, where we almost can't see it at all. Right? Each of these sides of the cube is called a face of the cube. Next up, what we need to talk about is, we're not going to leave it like this. What we need to talk about is the corners. Corners in a 3D shape have their own name. Each corner is called a vertex. And the plural of that would be vertices. So this is a vertex. These are the vertices of the cube. You should also be writing this down, so pause the video whenever you need to and write this down in your notebook. Next up, we need to talk about the lines that show us the limits of the cube. So here, 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 all of these lines. All of these lines, and of course the ones in the back as well. In three-dimensional shapes, they are called edges. So these are the edges of the shape. Some edges have special names. So the edge that goes from the bottom up is called the height, because it shows us basically how tall the object is. The edge that goes from left to right or right to left is called the length, because it shows us how long the object is across. And the one that gives it depth, basically the one that goes towards the back or from the back to the front, is called the width, because it shows us how wide the shape is. So let's make that with colors. So the red is the height. And it's not just this specific side. All the sides that go from down towards up or up to down, they are all the heights. So if I tell you that the height is, let's say 3, it means that all of these red edges are 3. Next up, the lengths. I'm going to make them blue. And you know what? Let's make the word blue as well. Again, you should be writing this down. This will be necessary. So if I tell you that the length of a shape, three-dimensional shape, is 5, then that means that all the blue sides are the same. You might be thinking, well, didn't we say that they were all the same? Didn't we say that all the edges were the same? And yeah, you're right. But what if we had a shape like this? Then they are definitely not the same. So here you can see that the blue ones are much longer than the others, right? So that's where this comes in handy. And then we have the width. And here all the widths are the same. So now you know what each of the edges is called. Now, what do we do with all this information? We're actually not going to need these right now. What we need to do is make this a little smaller. Now, because we said that this is a cube, right? And each side each edge is 1 meter. That means that the volume of this one cube is, I would say, 1 cubic meter. That is the volume of this cube. That is how much space it takes up. And if you say, well, how did you find that? Well, this is the definition, basically, of 1 cubic meter. It is a cube that has all of its sides being 1 meter. Now, what happens if, let's say, we have another one right next to our first one, and another one, and another one? Well, in that case, as you can imagine, that's 1, 2, 3, 4 cubic meters, right? So I would say that this shape has 4 cubic meters. But what if we added another 4? And actually, you know what? Because this is getting a little confusing with the lines, we're going to give them faces, actually. So let's actually give one face, I'm going to give one face color, just to tell it apart from the rest. Okay, so now you can see pretty much the front face of this cube. And again, I said that if we make another one, that's 2 cubic meters. And then another one is 3 cubic meters. And then another one is 4 cubic meters, right? This is 4 cubic meters. Now, what if I told you, give you another 4? You'd say, well, okay, that's just 8 cubic meters. And you would be correct. Let's say we had another 8. But these, I want to bring them up front, in front of the others. Well, now you'd say, well, since I had 8 before, and now I have another 8, that would be 16 cubic meters. Well, what if instead of this, I gave you a shape? And I told you that this shape has a length of 8 meters. It has a width zoom in a little bit. Has a width of 2 meters. And a height of also 2 meters. Now, now that we have we have 3 of the edges, we can make the rest. Can bring this up here, this down here, and then move that up. But we'll see where exactly in a bit. Then we'll move this here. Oh, look at that. That's exactly. And then here and then here. Then we'll make all the widths. So there you have it. That's our 3-dimensional shape. And this shape, because not all of its sides are even, but as you can see, it has it looks more like a rectangle instead of a square. So the cube looks more like a square and is made up of squares. But this one is made up of rectangles mainly and some squares. So this face is a square and this face is a square. But because it has some rectangles in it, so this face here, this face up here, the one in the back, and the one in the bottom, what we call it instead of a cube is a rectangular prism. In Greek, we would call it orthogonio parallelepipedo. And let's say I asked you what the volume of this shape is. Well, what you may have already noticed is that its dimensions are the same, are exactly the same as this shape, right? Because sorry, I made a mistake here for writing 8. I should have written 4. So again, its dimensions are exactly the same as this shape because this has 4 meters across, so its length is 4, and this has 1, 2, 3, 4. Its width is 2, so it has 1, 2, and its height is also 2, so 1, 2. So when we're asking how many, what the volume is, it's basically like asking, well, how many cubic meters is this made up of? So it's like asking, how many of these little boxes could we fit inside this object, basically? Like if I made the cubes again from the beginning, right? That's actually, yeah, we can do that. And again, try to use your imagination as best as you can to imagine these as 3-dimensional shapes, right? One moment. So here you can see I've made my little cube again. So when I'm asking what the volume of this big shape is, I'm basically asking how many of these little cubes could I fit in here, basically. How many cubes is it made up of? How many cubic meters? Because again, this is a cube that has all of its sides being 1 meter. So what I'm asking basically when I'm asking for the volume of the object is how many of these cubes is this shape made out of? The way that I find that with just mathematics is I need to multiply the height with the length and then with the width. So in this case, I would say 2, that's the height, times the length, which is 4, times the width, which is also 2. And what I would get if I did 2 times 4 times 2 is 2 times 4 makes 8, times 2 makes 16. And given that I told you that I wanted to make this shape to have the same dimensions as this shape, and if you remember correctly when we were talking before, we said how many cubic meters is this made of? We made 4, then we turned them into 8, and then we turned them into another 8, 16. So that's what we got here. What that's saying basically is that we could fit 16 of these cubes in this shape. The shape is made up of 16 cubic meters. So I would say that the volume of the shape is 16 cubic meters. Tomorrow we will be discussing more shapes and how to find their surface area. So that's the area that covers their outside, basically. So that'll be all for today. I will see you guys again tomorrow.